the place value of decimals. As you already know, we have the headings ones, tens, hundreds, thousands, etc. That is because our counting system is to what we call the base 10. So if I have the number 1, I know that I write that in the ones house, and that means one whole. If I have a number 10 times bigger than 1, then we know that is the number 10. So it physically changes. Every time a number gets 10 times bigger, it physically changes by adding another digit. So when we write the number 10, we write it like this. So now we have 2 digits because we have become 10 times bigger. We have now 2 digits. If we have a number that's 10 times larger than 10, 10 times 10 is 100. It physically changes to having 3 digits, like this. And then if you multiply 100 by 10, 100 by 10, it will physically change to have 4 digits. This is every time we get 10 times larger, the number changes by another digit. So 1,000, which is 10 times 100, will look like this. Now the question is, what happens if we have a number that's 10 times smaller than 1? In other words, you need to divide 1 by 10. What do we do then? Well, here is 2 diagrams demonstrating the whole number 1. So this is one whole cake, and on the number line, I'm going to put the 0 here and the 1 there. That's our normal whole number 1. So what happens if a number is 10 times smaller? Well, if you think of the one cake, if I want an amount 10 times smaller, I have to divide the cake into 10 equal parts. I've done that here. What we want to know is how much is one of those 10 equal parts. Well, we know from our fraction work that 1 of 10 equal parts is 1/10. So I have shown on this cake 1/10. Now, if we look back at our counting system headings, I sometimes call them houses or places, then the house or place that's 10 times smaller than 1's is the 10ths house or the 10ths place. And I represent that with the small letter T, not the uppercase T. The uppercase T is tens, but the lowercase t is tenths. You must not get them mixed up. Tenths are 10 times smaller than 1's, and tens are 10 times larger than 1's. It's a bit like a mirror here at each side of the ones place. So tenths is always set to the right of the ones house, and we separate it with what we call a decimal point. So the decimal point separates the fraction parts, the parts smaller than the number 1, from the whole numbers, our normal numbers that we count on a number line. So here are your whole numbers, decimal point, and to the right of the decimal point are parts of a whole, fractional parts of a whole. It's always tenths. Tenths is always the place after the decimal point. We're not writing quarters or halves. It's the digit in here will always be worth tenths. And since here you know that you've got 1/10, you will write the number 1. So I put my 1 in the tenths house, and to show that it is the tenths house, I put the decimal point before. That's my 1, and I usually put a 0 here, just so you can clearly see the point in between. So this number here represents 1/10. So this is the same as this here. 1/10 is the same as 0.1. There are just two different ways of showing the same thing. 1/10 is a fraction, 0.1 is what we call a decimal, which is really short for decimal fraction. All right, now look at our number line. I've told you that these are fractional parts. They're not as big as whole numbers. They come between the whole numbers on a number line. So if this number line represents 0 and the whole number 1, which is the ones house, then what are the numbers in between? Well, the numbers in between are not as big as the whole number 1, but they're fractional parts. And in order to know which fraction, you have to count how many lines there are. So if I start at 0, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal parts, just like my 10 equal parts here. So each of those lines is worth a tenth. So the first one, for 0.1, I would need to put it here. Then the next one would be 0.2, 0.3, all the way up to 0.9. And of course, after 0.9 comes the whole number 1, because 10 tenths is the same as 1 whole. 10 of your tenths is the same as the whole number 1. 10 of your tenths is the same as the whole number 1. So that's where the tenths would come. What about the hundredths? Okay, the hundredths house or place comes after the tenths. You should realise that going this way, the number becomes smaller and smaller and smaller and smaller. It becomes 10 times smaller each time. Going the other way, the number gets 10 times bigger. 10 times a tenth is 1. 10 times 1 is 10. 10 times 10 is 100, etc. So this direction it gets larger, this direction it gets 10 times smaller each time. So which makes sense, because our little hundreds, and I apologise, these should all be the same size, but it was difficult to draw. So my hundreds are smaller. One of those little hundreds is smaller than one of my tenths, 10 equal parts. And I coloured in here 1, 2, 3, 4 of those little hundreds. So how would I write 4 hundredths as a decimal? Well, to write it as a fraction first, 4 hundredths, and then as a decimal. Well, here's my hundredths place, so I'm going to put my 4 in the hundredths place. The other headings are place value holders. I'm going to put a 0 there, and my decimal point to show it's a decimal, and my 0 there. I have to use these zeros to make sure that you see that the 4 belongs in the hundredths place. So 0.04 is the same as 4 hundredths. 0.04. On my number line, and I really do have to apologise here, this I couldn't fit 10 little lines in between each, but my hundredths would mean I'd need to have 100 little lines all the way from 0 to 1. Between 0 and 1, 100 equal parts. And each of those would be worth 100. So 400 hundredths would be roughly just before halfway between the 0 and the 0.1. So it would be at 4 of those little hundredths lines. 1, 2, 3, 4, and it would be written as 0.04. 0.04. What about if we look at my one of the 10 equal parts, 1/10, which if you remember, we write as 0.1. That's 1/10. And then we look at it as hundredths. So my one of 10 equal parts, how many little hundredths are coloured in? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we can see that 10 of our hundredths is exactly the same as one of our 10 equal parts, which goes to prove that 1/10 is equal to 10 hundredths. 10 hundredths. 1/10 is the same amount as 10 hundredths. So here we can see as well on our number line that 10 of those little hundredths is the same as their 1/10. So we can easily write here that 10 over hundreds, which I'll write now, is the same value. They look different because there's a 0 at the ends in the decimal form, but that 0 doesn't matter. This amount is exactly the same as this amount. They both mean the same thing. 1/10 is the same as 10 hundredths. And if I made these even 10 times smaller, each of those little boxes, I would get thousandths. And 1/10 would be the same as 10 hundredths, and 1/10 would be the same as 100 thousandths. Isn't number wonderful? Anyway, I've been demonstrating very much with the number 1 and tenths and hundreds. What if you had 25 hundredths? Well then, if I wanted to write 25 hundredths as a decimal, I would just have to write 0.25, because that shows me that 25 is in the hundredths. 25 hundredths. Here I'd have to shade it in. I've shaded in 10. Oh, let's do it red. 10, 25. That would show 25 hundredths. I could have also shown it up and down the way, which maybe makes a bit more sense. That would be 10, 20, and then 5. 1, 2, 3, 4, 5. That would show 25 hundredths, which I would write as a fraction. 25 hundredths equals 0.25. And there, that's 2 tenths and 5 hundredths. If we look here, that's 1/10, 2 tenths and 5 hundredths. 2 tenths and 5 hundredths. 2 tenths and 5 hundredths, which all together is 25 hundredths. 25 hundredths. Same. You can split it up into tenths and hundredths, or just call it all hundredths. Thank you for watching. Goodbye.